Hello everyone, today we're looking at Unit 0, Lesson 4, the standard form of a line and the x and y intercepts. Okay, so we're going to look at what's the difference between that y equals mx plus b form we've already learned with this new form called standard form. So if you look at this table, there's more than one way to write the equation of a line. We can use y equals mx plus b, which is what we've learned about so far in this unit, or we can use standard form, which is what we're going to look at down below. So today we will look at the standard form of equation of a line. The different forms of a line give us different information about the line. So have a look. We're going to talk about and highlight some of the key points here. If you have a look at this table, everything on the everything on the left-hand side is an equation in proper standard form, because there's very specific rules about what proper standard form is. Everything on the right is not in standard form. So if we look here and kind of compare side to side, we have 2x minus 3y minus 6 equals 0. Well, the one right next to that looks similar. The only difference is which saying it's then not in standard form is this negative. So there might be something there with having a negative in front of that first term, maybe. We'll keep going. If we look through here, we can see that this is on the other side of the equation. That's a bit different. And then the next one, y equals 3x plus 2. Oh, well, that's just that slope y-intercept form. So that's different. The same is true of the next one. If we look at the next one down, so now I'm over here, 1/2 x plus y minus 5, they're saying that's not standard form. Well, we don't have any negatives here, but this looks a little bit different with the fraction. So it looks like maybe we can't have a fraction in standard form. And carrying along with that, this one looks okay, except for there's a decimal. So it must be something wrong with that as well. And then finally, if you look at that last box, it looks like I have x's and y's here, but they're saying that's also not standard form. The only thing that looks a little different here is the fact that we have some zeros maybe. So let's try to summarize some of these rules for standard form. First of all, the general formula for a line written in standard form is going to be ax plus by plus c equals 0. And we're going to summarize some of what we're kind of seeing in that table above. So it says, in the table above, we found that a, b, and c are what we call integers. So that means they are positive or negative whole numbers. There are to be no fractions and no decimals. So you can see that here. This one had a fraction, this one had a decimal, and that made it not standard form. Okay, the letter A cannot be negative. So you'll notice the form is ax plus by plus c, right? So those represent what we call coefficients or numbers. If we look at our first example, you could see I could say A would be 2, B would be -3, and C would be -6. So it's just what numbers go in there by our variable terms or by our letter terms. And the last one, A and B cannot be both equal to, in this case, is 0. So you can see here, we had A and B were both 0, okay? Can't be so. If you look over on the ones that were correct, so for example, let's look at this one. We could write that out as x plus 0y minus 5 equals 0, right? Because 0y would just be 0. And that one would still be saying, okay, this is correct, this is in standard form, because only one of them are 0, not both. So just remember those rules, okay? It's in that ax plus by plus c form. Gotta be integers, no fractions, no decimals. That first coefficient a cannot be negative, and a and b cannot both be equal to 0. So number 1 says, do you think negative 3x plus y plus 4 equals 0 is in standard form? Why or why not? So I'm going to take this one first, and there's a negative there, so there's a negative on our a, so it can't be in standard form. So no, because a is negative. Okay, the next one says, do you think 8x minus 3y equals 6 is in standard form? Why or why not? And this one to me looks very similar to this second one in our table above, where we have the constant on the other side of the equal sign. So that put it as being not in standard form. So I'm going to say no. C, so that constant of C is on the wrong side of the equation. I'm going to try one more together, and then you guys can try that last one. Do you think 9x minus y equals 0 is in standard form? Why or why not? Okay, so we have our x, we have our y. We could assume that there's a constant of just plus 0 if there's nothing written there. So it looks like everything's checking out. There's no fractions, there's no decimals. Our a is not negative, and a and b are both not 0. So we can say yes. The equation is equal to 0. And I'll say follows proper format. Pause the video and see if you can try that last one on your own. Okay, so hopefully we identified that yes, in fact, that last one is also in standard form. We have an a that's not negative. Okay, a, b, and c are all integers, and a and b are both not 0. So it works out to be in standard form. Okay, so now we're going to look at kind of going between those two forms. We've taken a look briefly at standard form. We've spent a few more days on slope y-intercept form. Let's see if we can figure out how to switch from one form to the next. So we have x plus y minus 3 equals 0. So let's just remember that our slope y-intercept is going to be y equals mx plus b. So we want to try to isolate that y. So if I look at my first equation, I want to keep y, right? I want to isolate it. If it's already positive, I might as well leave it on that side of the equation. So I have to move this x over. I'm going to have to move this 3 over. I'm going to leave the y there. And if I move the x over, I'm going to subtract x. And when I move the 3 over, I'm going to have to add 3. Okay, and then it says, let's identify what's your m value and what's your b value. So my m is going to be -1, and my b value is going to be a positive 3. And we'll say our y-intercept then is 0, 3 if we're going to write it as an ordered pair. Okay, so let's just write a few notes about what we did here. You'll notice that I said first we need to leave that y alone. So we're going to leave that term, and I'm going to put it with a b because sometimes there's a coefficient on it. We're going to leave that by term on the left. Okay, and then we're going to work to move ax and c to the right. Okay. In this case, that's all we have to do, but we're going to try another example and see if there's anything additional we might have to do. So again, I'm going to leave my y there. I'm going to move x over, and I'm going to move that -4 over. So we'll have 2y equals, and this time we'll have a -x, and move that 4 over, we're going to add it. Okay, but we're not quite in that y equals mx plus b form because we still have to deal with this 2, right? We got to get y all by itself. So our algebra rule say it's being multiplied there, so to get rid of it, we have to divide everything by 2. So we'll be left with y equals a -1/2 x, and then 4 divided by 2 is plus 2. So now we could identify our slope as a -1/2. Remember, that's the the coefficient on my x, and we can identify our y-intercept as 2, or we would write it as a coordinate of 0, 2. So this actually added one more step to our process. Right, we left the by term on the left. I'm going to put those in quotations. And then we moved ax and we moved c to the right. Right, so that was all here. Our last step was that we had to divide everything by 2, which 2 ended up being that b, right, that coefficient on my y. So we're going to divide the equation by b. Right, that's that last part. I'd like you to pause the video and see if you can do that third one all on your own. Okay, so there's the solution to that equation. We moved over the 6x, we moved over the 15, and then we divided by that -3 to get our equation, and again identified our slope and our y-intercept. Okay, so that is us going from standard form to slope y-intercept form. The next part says let's change from slope y-intercept form to standard form. So now we need that equation to look like our standard form, which is ax plus by plus c equals 0. Remembering those rules, okay? So ABC must be integers, no fractions, no decimals. A has to be positive, and A and B can't both be 0. So we'll keep talking through those rules as we go. Knowing in this case that we have to make sure that this is positive, I'm just going to write must be positive. We're going to keep that in mind as we move things to say, okay, which direction should I move this term to ensure that x is going to be positive? So for example, if I look at the first equation, y equals -4x plus 1, I need this to not be negative. So that's really simple. I could just move it over to this side of the equation, and that will make it positive. So I'm just going to move everything over to that side because that's what I'm trying to do. I'm trying to move everything to one side so that it equals 0. So I'm going to move a -4x over. It's going to be a positive 4x. The y is just staying on that same side, so I don't have to do anything there. And then I move the 1 over by subtracting 1 equals 0. So again, let's just make a little note about what we're doing here. I'm going to just go like this. So we're going to take a little note. So we're going to say rearrange to ensure ax is positive. Okay, so when we're rearranging, we're going to watch for that. Let's take a look at that next one and see if there's any other steps we might need to add. Okay, this time my x is already positive, so I don't really want to move it over to the other side of the equation because then I'll have to subtract it and I'll make it negative. So I'm just making more work for myself if I do that. So instead of moving the x and the 3 to the left, we're going to move the y over here. Doesn't matter if that y is negative. So we're going to have x, we're going to subtract y, and again the 3 stayed on that side. So it's a plus 3 equals 0. So no big change there. Let's look at this last one and see if we run into any more kind of problems we're going to have to work with. Okay, so we have y equals a -2/3 x minus 2. Well, since I have this negative here, I might as well move this whole term -2/3 x over because I'll be able to add it, which will make it positive. So we'll add 2/3 x to the left. We're going to leave that y on the left where it was, and then we're going to bring that 2 over by adding it as well. Okay, so looking at that quickly, we might think we're done, but we can't have fractions. We have to remember no fractions. So how do we take care of that fraction? We're going to multiply everything by our lowest common denominator. We only have one denominator in this case. We'll multiply everything by 3. So we'll have 2/3 x. And we're going to multiply that by 3. plus we're going to have y, and we're going to multiply that by 3, and we're going to have 2 multiplied by 3. Okay, so if I multiply 2/3 by 3, those cancel out and we're left with just 2x. 3 times y is 3y, and 3 times 2 is 6. Okay, now we fulfilled all those rules. A, B, C are all integers, A is positive, A and B are not both 0. So let's just write what we did that was a little bit different in this one. Okay, we're going to multiply by your LCD, so by LCD to clear fraction. And I'll just put in brackets, only if necessary, right? You might not have a bracket, or sorry, you might not have a bracket, you might not have a fraction. So only do that if it's absolutely necessary. So to go from slope y-intercept form, we're gonna get everything over to one side of the equation, making sure AX is positive. And if we have any fractions to deal with, or decimals, we're gonna multiply to get rid of those or make them whole numbers. Okay. So just quickly, we're going to talk about x-intercepts and y-intercepts, which we've already chatted a little bit about y-intercepts in terms of the equation of a line. So an x-intercept is where a line crosses the x-axis. So I'm gonna draw it on here. I'm gonna erase it in a minute. But if it's crossing the x-axis, let's say here, okay. Something to note about this one is that that point is -5, 0. So you can see my y value in this case is 0. If I cross my x-axis here, okay, my x-intercept is going to be at 2, 0. Again, my y value is 0. So no matter where your x-intercept is, your y value is always going to be 0. So we're going to say y always, that looks like it's part of the same word, y is always 0. Right? Y is always equal to 0. And the same is going to be true when we think about our y-intercepts, which we've already seen. We talk about if I had a line, and let's say we don't have to have vertical lines like I just drew. Let's say I have a vertical line. Where does that cross my y-axis? It's crossing right there. So you can see that that point is 0, 4. Let's say I have another one that's something like this, right? Where does it cross my y-axis? Okay, that's going to be at 0, -8. So again, notice my x value is always going to be 0 for a y-intercept. So we can say x is always 0 when we're talking about our y-intercept. So knowing that information, we should be able to use that information to help us find the intercepts of a line. So if they gave us an equation in standard form, how can we find our x and y intercepts? So let's first start with our x-intercept. So knowing what we know here, okay, our x-intercept, y is always going to equal 0. So for our x-intercept, if we know y equals 0, let's just sub that value in. So we're going to sub in that y equals 0. I'm going to have 2x minus, I'm going to sub in a 0 for y. Okay, so that 0, we don't need it, so we'll have 2x minus 7 equals 0. And then we'll just slowly start isolating. So I'm going to bring that 7 over to the other side by adding it, and then I'm going to divide both sides by 2. So you're going to have the x is 3.5. And if we wanted to write that as a coordinate, we could say our x-intercept is 3.5, 0. Okay, I'm just going to draw a line to separate these two. And then we'll take a look at our y-intercept. So our y-intercept, keeping in mind what we just said here, for our y-intercept, x is always equal to 0. So we're going to sub in x equals 0. So we have 2, and then in place of x, I'm going to put a 0. minus y minus 7 equals 0. So 2 times 0 is just 0. We're left with negative y minus 7 equals 0. And then I'm going to bring my y over to this side because I'm trying to make it positive anyway. So we'll have a negative 7 equals a positive y. And again, if this is my y-intercept, we can write it as a coordinate of 0, negative 7. Okay, I'm going to plot those points so that I can draw a line. So my first point I'm going to plot is that 3.5 and 0. So I'm going to go over 3.5 and up 0, so something like that. And then my next point is 0, negative 7. So as soon as you have two lines, you're able to essentially draw a line. So I'm just going to pull my ruler up so that I can draw a line connecting those dots. Okay, and we'll make sure that we put some arrows on there, and I'm going to label that as line A. But you can see as soon as you have 2 points, you can plot those and then connect the dots, and you're able to draw your line. Okay, I'd like you to pause the video and see if you can work through finding the x and y intercepts for that next example, and then graph it on the graph to the right there. There is the solution to the next one, so have a look at substituting in a 0 for our y to find our x-intercept, and then substituting in a 0 for our x to find our y-intercept, plotting those points, so negative 5, 0, and 0, 3, and then connecting those dots to make your line, ensuring that we put arrows on the ends of those because those lines go on infinitely, and I've just labeled that as line B. That's all for your notes for today.